Okay, this is question 2 for your final exam. What happens if you get this question? How do you answer this? Well, if we start off, what is the bicarbonate ion carbonic acid buffer system? It is a buffer system that prevents radical shifts in pH. A buffer system that prevents radical, that means major swings, shifts in pH. And we're talking about blood pH overall. Please write it out and label all of the parts. Well, of course we can do that. When you have to write it out, you have to write water plus carbon dioxide, and you can do this in any order, carbon dioxide first if you want. But here I can say that two H's, one C, three O's. Here's 1, 2, 3. So add those together and we get carbonic acid. We have to label these carbonic acid. As lazy as I want to be, I'm going to go through it. Carbon dioxide. Okay. And carbonic acid will break down to release hydrogen ions and the bicarbonate ions. See how we have two H's from two H's, one C, and three O's. And if we have a plus here, we have to have a minus here. So this is our hydrogen ion. This is the thing that contributes to pH, and this is our bicarbonate ion. Bicarbonate ion. So that's what we do for B. Where is it? We know, if we've already watched question 1, that this is found in the blood, specifically in the plasma. Now, it does occur, but not in the way as a buffer system. It does occur inside red blood cells when we're trying to convert and carry carbon dioxide in the respiratory system. But let's leave it at in the blood. Also, I need to put these arrows in 2 directions because this system is normally in equilibrium. Okay, so if this system fails in maintaining pH, what body systems have to take over? Well, the respiratory system does, and the urinary system or the renal system. I don't care how you say it. I'll know what you're talking about. That's URINARY, the urinary system. Okay, so now we're going to do something different. In the first test, we were doing metabolic acidosis. Now, because a patient has COPD, this is going to be a respiratory acidosis, correct? And so COPD, one form of COPD is emphysema. And what is happening here, if you want to keep this in mind, is that carbon dioxide builds up. In the blood. Now that's going to have consequences, right? It's going to build up because in emphysema, the walls between the alveoli break, and upon releasing air, there is, I guess you could say, the airways collapse and you trap carbon dioxide. And so it's going to build up. So how would this affect the pH of the patient's blood? Well, if anytime we increase carbon dioxide, we're going to shift this equation to the right, and ultimately we're going to release hydrogen ions. And remember, hydrogen ions are what affects blood pH. And so how would the patient's blood pH be affected? Well, pH is going to decrease. You end up with a respiratory acidosis because your pH is decreasing because of the respiratory system. So exactly how is this buffer system overwhelmed? Show on the buffer system and describe the directional shift. And so like we were doing before, write this out a little cleaner. Water plus carbon dioxide makes the bicarbonate ion, which releases hydrogen ions and, the carbonic acid and the bicarbonate ion. I misspoke. Well, instead of it being equilibrium, like we have up here with these arrows going in both directions, in this case, as we increase carbon dioxide, we're going to shift the equation to the right, meaning excess carbon dioxide will be attached to water to form carbonic acid. And carbonic acid, they'll get a lot of that, and then it will break down and release a lot of these two things. This right here, hydrogen ions, is what contributes to pH. So it shifts to the right, shifts this equation to the right when we when we have a lot of excess carbon dioxide. So we have an increased amount of hydrogen ions, and therefore we have a decrease in our pH. Oh, next question. In this situation, which body system can help the person maintain a relatively normal pH? In this case, we only have one body system because the respiratory system is messed up. So here it's going to be the urinary system. And what we can do, remember, we have excess hydrogen ions. So what the urinary system will do is it will get rid of, out of the body, it will secrete hydrogen ions, and it'll take out of the urine and put back into the blood bicarbonate ions. So it will resorb excess bicarbonate ions. So congratulations, that is called, this is a renal compensation. Up above, we have renal compensation for a respiratory acidosis. Up above, when we had a metabolic acidosis, we had not only renal compensation, but we had a respiratory compensation as well. Okay, so let's go to the next one. No, let's stop the recording right here. That'll be the answer for number 2, and then we'll do probably 3 and 4 together because that's not too bad, and split 6 up. All right, that's the answer to number 2.